everybody. My name is Kevin McLaughlin. I'm the director of the John Nicholas Brown Center. I just want to welcome you. I'm going to do very brief remarks and then introductions since we really have an hour. Really appreciate your taking time out of your busy week to come and join us here on the outskirts of the Brown campus. And so let me welcome you first to the John Nicholas Brown Center for Advanced Study, a recently launched center dedicated to supporting faculty projects to communicate the importance of faculty research to non-specialized audience. If you're interested in learning more about the center, I won't say more about it now, please go to our website and sign up for our newsletter, and we'll be happy to include you in the mailings. Again, as I said, my name is Kevin McLaughlin. In addition to being director of the John Nicholas Brown Center, I'm also a faculty member here at Brown in English and Comparative Literature. Some of the faculty members in the room today who might have been hired from 2011 to 2022 might have seen my signature at the bottom of their offer letters when I was the dean of the faculty. So if that's the case, I'd be delighted to finally meet you if we haven't met. Let me begin with a few thank yous very briefly from my colleagues here at the JNBC for helping us organize this event. First, Maria Sokolova, who you may have seen on your way in, who's the JNBC manager. I want to thank also Ron Potvin, who's the Nightingale Brown House. That's the name of this building. He's the curator and facilities manager here. You may have seen Ron, he was there too. And finally, Victoria Lee Hood, who is the JNBC Senior Fellow. And Victoria also leads a new structure that we've invented that we're calling the Public Engagement Accelerator. Again, you can go to the website if you want to see a more detailed description of that. So today's gathering is the first event in a collaboration between the JNBC and the Office of the Provost, and thank you, Provost Doyle, for being here this afternoon, and in particular with Associate Provost Michael Littman on a series of conversations about AI that we're calling BR-AI-N-storming. The word, in addition to the word brainstorming, the word conversation is key to this set of events.
Which also has an A and an I in it, just to point out.
Okay.
They're just not next to each other this time.
Okay. So these events are meant to be entirely unscripted and informal, and like a good improv, they are supposed to involve dynamic interaction between the audience and the principal actors, whom I will now introduce. First, in the middle, Emily Oster. Emily is the J.J.E. Goldman Sachs University Professor of Economics and founder and CEO of Parent Data, a data-driven guide to pregnancy, parenting, and beyond. Parent Data's weekly newsletter now has hundreds of thousands of subscribers along with a strong social media community. Emily's also a New York Times best-selling author whose books with amazing titles include Expecting Better, Crib Sheet, The Family Firm, and The Unexpected. Next to Emily, to her left, is Loukas Gouskos, Christopher M. Barter Assistant Professor of Physics. Loukas joined the Physics Department at Brown in 2023 after holding the position of Experimental Physics Research Staff at the European Organization for Nuclear Research, or CERN. Michael Littman, to my immediate left, is going to be sort of moderating this discussion. Michael is University Professor of Computer Science and Associate Provost for Genuine Intelligence, as well as Artificial Intelligence. Genuine Artificial Intelligence, maybe.
Artificial Genuine Intelligence.
Isn't all intelligence artificial? Anyway, that's a question. Okay. So Michael is also a fellow of the Association for the Advancement of Artificial Intelligence and the Association for Computing Machinery. And recently, Michael served as Director for Information and Intelligence Systems at the National Science Foundation. He is the author of, among other publications, a book that is especially attuned to the public engagement mission of the JNBC, entitled Code to Joy: Why Everyone Should Learn a Little Programming. Michael will get the dialogue started with Emily and Loukas, and then we'll expand it to the entire group. Let me just ask you before we begin to turn off your cell phones if they're on. And let me turn it over to Michael. Thank you again for coming.
All All right, thanks, Kevin. Hi, everybody. I'm Michael Littman. I guess I was already introduced, so I don't have to say who I am. But I do want to say that one of the things we're going to try to have, slightly different than a lot of these kind of moderated panel things, is for them to talk mostly to each other, and for Kevin and I to just kind of hang back a little bit, and to really have a conversation that crosses the disciplines. And so that's kind of our goal. We want to, again, as Kevin pointed out, involve all of you as well. But we designed this series with the idea that we would bring together two really interesting people with two fairly different backgrounds that yet had some overlaps. And so hopefully through the conversation, some of those overlaps will be revealed, and we'll get a sort of a broader picture about artificial intelligence and the sort of academic pursuits more generally. So I thought it would be good to kick things off. Since the title of Brainstorm is AI Crossing the Disciplines, could you tell us a little bit about, and briefly because we want to get into the AI part, but what is your discipline? Like, what does that mean? You're an economist and a physicist. I think we all have kind of a cartoonish version of what that means, but tell us a little bit better about what your discipline is. So Emily, you want to start?
Sure. So I'm an economist by training, and I think that most of the time when people sort of outside of the academy, certainly, and even to some extent inside, sort of think about economics, we're thinking about stocks and bonds and the kind of things that are in the macro economy. The reality is that most of the economists working here and also kind of broadly in academia are probably not doing that and are doing more of what we think of as microeconomics, a lot of work that would look a little bit more like statistics. There's a lot of work with data, thinking about social problems, thinking about social programs, trying to do program evaluation, trying to generate causal estimates of, if we do the following policy, what will happen. And so in my particular case, my academic work is about sort of health economics, but also about statistical methods. So I think about questions like, why don't people make the health choices we think that they should, but also questions like, how do we learn causality from observational data, and is it possible to do that, and what are some of the limitations of that? So that's sort of economics, and then that's what I do within it.
Yeah. So I'm a physicist. So there are many branches in physics. So I'm a particle physicist. So my goal is to understand how nature works, right? So we want to study the particles that we have seen, we have observed, but maybe indirectly find new particles or directly. So think about, like at the LHC, at CERN in Geneva, we collide particles 40 million times per second, right? And in every collision, we go back like a few billion years, where everything almost started, the Big Bang. And we try to see these patterns and understand the physics, the dynamics, how nature works.
Is it clear to us what a particle is? Is like dust a particle?
A particle or a wave. Now we go
to
be very technical.
I withdraw the question.
They are very light, so probably you can treat them as waves effectively. We also have a wave nature, but we are heavier. So
we meaning people or physicists?
We people.
Humans?
Yeah.
Okay, all right. Yeah. So that's kind of where you're coming from, the kind of questions that you were inspired by, what you're trying to solve. My research area is artificial intelligence. I've been studying this for, 40 years or something like that. But now artificial intelligence is kind of in everything. And so what is the impact within your discipline and in your work in particular of these ideas about artificial intelligence? Like, what does that even mean? I think a lot of people hear the phrase artificial intelligence. Maybe they're thinking about a chatbot, or maybe they're thinking generally about anything a computer does. It's a very broad, the term is used in a very broad and non-specific way. So in your lives, in your work, what does it mean to you? So Loukas, you want to kick us off?
Maybe, yeah. So artificial intelligence is a tool, right? A very powerful tool, but it's a tool, like as detectors, like devices that we detect particles is a tool. Artificial intelligence is a tool. So when we try to understand how nature works, we're talking about big devices, detectors, like 4-store, 5-store buildings with 100 million channels, producing every time we have a collision, tens of thousands of particles. So we want to exploit correlations between the particles to find patterns, right, that could lead us to a new particle, a new interaction. And there is artificial intelligence is very powerful. For instance, one task is to identify the types of particles. So artificial intelligence is very powerful to exploiting correlation, nonlinear correlation. So this is one example, there are many more, right? So it's great to have artificial intelligence because it allows us to exploit the true potential of our devices. Soon, in 5 years, it will become a need. We need artificial intelligence because otherwise we cannot meet the computing constraints we have.
I mean, because you will have already learned, because you will adapt the work into having the AI, and so then it will become necessary, or?
Because we're never happy, we're very ambitious, so we're going to build an even bigger experiment, collide even more particles. So the resources, even extrapolate, even assuming that we're going to increase the computing resources and infrastructure, is not enough. So what we want to use AI to make, for instance, the reconstruction of the signals to something that is more human understandable faster. It's active R&D, but it's a need. If we project now, we just cannot operate our system.
So I think the way that economists would think about using this in our current moment is in some ways similar, in some ways not. So I think that the tool frame is right, but the ways we're using this are probably more varied and less central. So I think, one of the things that a lot of AI chats, a lot of AI, agents are very good at is coding. This is they're very good at coding. And so people who, if you're coding, we have research assistants, or we have people are coding in Stata, there's a lot of things you can just now have some bot do for you, and that has, I think that changes the kind of technology. I suspect we are moving quite a bit more slowly than you guys, because the time savings and it's sort of I could have this chatbot do this instead of having some RA do this. And that saves me a little bit of time. But it doesn't mean that much time. The chatbot is sort of worse than the RA. It's not, but in some ways, better in other ways. So I think we're sort of slowly iterating towards small efficiency gains. But I definitely do not think, in the way that economics is practiced now, that I would say in some short period of time this will be necessary. It's I think it's just not changing the technology as much, and maybe that's because of the sort of lack of ambition. Maybe there's more ambition in some that we could have, but I don't think that's where we are.
That's really interesting.
Yeah, I think that's right.
So a follow-up question that I was imagining Emily might ask Loukas is, when you described the which
I failed.
No,
I did ask a follow-up, but it wasn't the right one.
No, it was great. Yours was great. Oh, I didn't mean it that way. That Loukas pointed out that AI in the work that he does involves taking a lot of data and finding patterns and so forth. But I feel like we used to have a name for that, and it was statistics. And you said in your work, there's a lot of, in your field, there's a lot of statistics as well. What's the difference there?
So I will tell you what I think the difference is, and I'm curious if this is what you. So it sounds like some of what you are doing is almost sort of free form, asking the AI to find patterns, which you then can use in sort of hypothesis generation and testing. Is that right?
To very large, to some extent. I mean, becoming more and more important on pattern finding. But if we want to really squeeze the performance, really have a powerful algorithm, we have to inject physics knowledge. So domain knowledge is fundamental. We have examples, I'm not going to go in details, that are very models with huge capacity, billions of parameters. So in principle, you say, they're going to learn everything, you train it a long time. In practice, you need to have domain knowledge, as we say in data science, you need to inject the physics knowledge. Then, it helps us. Of course, we say this is like a Higgs boson. It's something that potentially interesting. We separate against physics we know. And then we have to do statistical analysis, hypothesis testing, for instance, which I think there should be a lot of similarity between economic.
And I think for us, we are just doing the hypothesis. We're sort of, a lot of what we're doing is how do you come up with a hypothesis? You don't need AI to come up with a hypothesis. We're coming up with hypotheses either by being we did this policy, the hypothesis is that it worked or it didn't work, pretty basic, or we have hypotheses about how people will behave, which you generate more or less by introspecting about your own feelings. And then we're going to sort of test those in data, but the way that we would test them in data, it's not the sort of core element there for us is like, is there an experimental component? And you guys are generating the experimental component. We gotta like find it in the world.
Yeah, we generate. There are, of course, simplifications and assumptions when we generate like simulated events, for instance, or the components. On the other hand, we don't, and we are in a unique position in physics. We don't know. We have strong hints. We have dark matter, which is like 25% of the universe, right? Dark energy, 70% of the universe. We're just 4%, right? The stars, us, it's just 4%. We know there's new physics there, and we are in a unique position. We don't know where new physics is. Like before the LHC, we knew that we had to find the Higgs, the particle that gives mass to us. We had a no-lose theory. Now we don't have. So it's not only, we don't have a hypothesis. Maybe what we're looking for is not how nature chose to behave, let's say. So we have to do what we call anomaly detection. So we don't test on a specific hypothesis. Instead, we learn very well the physics we know, and we typically AI can interpolate but not extrapolate. So if it sees something new, it will flag it as potentially an interesting signal.
So one of the things I think is really interesting is that in some of the work that you're describing, so me as an AI guy, a neural net guy, I would try to build a neural net model of some kind of phenomenon in the world, and I don't know physics, so I wouldn't include any knowledge about physics in my model. I was like, oh, the data, it'll just work it out on its own. But what physicists point out is like, wait, we know a lot about physics already. Like the network shouldn't have to rediscover the stuff that we human beings have actually spent the last couple hundred years working out. Like build that into the network. I feel like economists could have a similar kind of reaction, that they look at the stuff that we're doing and like, you're not thinking like an economist, right? That there's incentive structures. Well, because sometimes now the big future thing is going to be agents. Well, what are agents? Agents are like decision makers that are interacting with each other and trying to come up with actions about what they're going to do. Should we be looking at economics as a source of how to design these kinds of systems to make them behave better?
Maybe. I mean, I think that for a lot of it, like this kind of sort of agent-based modeling is not a super central part of like I think economists are generally like way more practical than you are giving us credit for, or maybe less general. Like I think so much of what we want to sort of see in the world is just like, how do actual people interact with this? And I actually think this is a limitation to where, like, I think there are many people who are like, we're just going to learn all about the economy by developing a bunch of agents and having them like talk to each other, and that's going to tell us about, and I mean, I think that's like ridiculous, because people, it's very, very difficult. Like people are much more complicated than anything you could code in, and every time you do something, they react in some different ways. There's sort of no, I'm not sure we're going to get to a way where like a kind of computing model can tell us what we would learn if we did a policy, right? Which is ultimately where you sort of say like, okay, we're going to experiment, like instead of just doing this policy, we're going to like code up some agents, and we're going to do the policy to the agents, and we're going to see what's going to happen. I do not think that will ever get you the correct answer.
Yeah, I agree. I mean, one could think that they're similar, and they are similar, but every time I collide beams, one collision with the other are independent cases, doesn't affect one each other, right? In economics, you have some what I call soft constraints. You have to deal with human nature, right? I mean, a decision can affect the next decision. So how you incorporate, of course, we have techniques in AI, but it's not so trivial. And also you have, in addition, other soft constraints like laws or other things that you have to take into account, which we don't care in particle physics about this. So.
Well, so the sort of thing I had in mind actually was, I read a paper where some AI lab, they said, oh, these bots are so smart. They're obviously so much smarter than people. We'll let them run a store. We'll let them actually be an economic agent, and it will actually run a vending machine. And then people will like, I don't know, make interact with it and buy products, and it'll figure out what inventory to keep and what prices to charge for things. And it was an absolute disaster because people just convinced it is like, oh, you know what we really need is tungsten cubes. And the bot was like, you're right, I should stock tungsten cubes. And it spent a ton of money on tungsten cubes, and then nobody bought them because who needs tungsten cubes? You might need tungsten cubes.
Yeah, we need tungsten.
Right. All right. But anyway,
from a vending machine.
right. But from the vending machine, and so I'm reading this paper and I'm like, oh my gosh, where are the economists? Like, where are the people who actually know? You don't just throw out and arbitrarily try to have the bot figure it all out from first principles. Like, we know some things about what it means to be an efficient trader of goods.
But then I think you're back to, so I totally agree with that, but then I think you're very much back to Loukas' first point, which is like, this is a tool, right? Like, if you are a person who runs a vending machine company, there are absolutely things that like you should be using AI for, right? You should be having it think about your inventory. You should build an agent that like does it, like runs through all this stuff for you and looks at all this complicated. I mean, this is what AI is going to do in terms of jobs. It's going to like sort of systematize and improve the efficiency of a set of things which otherwise somebody was going to read all these things on a spreadsheet. Like, now the AI is going to look at your output, and it's going to come back to you with some suggestions about what you should do. But then you as the person are going to go look at like these things, and then when the AI comes back and it's like, buy a bunch of tungsten cubes, you're gonna be like, you know what? No. And then you're gonna teach it something better. So I think we are probably overestimating the independence of these models and underestimating the kind of Centaur tool version of this. And I think
Centaur, when you say Centaur, that's like the machine and a person working together to solve a problem.
Yeah, exactly.
Like a horse and a person working together to solve a problem.
Right. And I think if you talk to these, like, it's sort of an interesting, so I go yearly to this conference full of like AI weirdos, and when I was there like 2 years
I've
ago,
not been invited.
like you haven't been perhaps. So like 2 years ago, I think there was there was a sort of much more of a kind of people who were like, AI is gonna. There were sort of the AI doomers, and then there were the people who were like, AI is going to change everything, and like people are going to replace, and it's going to be like WALL-E, where we all just sit and like our AI butlers like serve us cake, and like that they've made, it was like that was like the sort of 2 years ago vision. And I think when I went this year, there were many more people who had like kind of come to the middle, sort of where these like Princeton guys are like, AI is a normal technology. Like, here are the ways in which it's going to change what we're doing. Here are the ways in which it's not. But like fundamentally, we are not in the current models. We are not at a place where this is likely to be able to replace people, even for a relatively simple thing like stock the vending machines. And that actually there isn't, and this I think is a little more controversial, but there's this question of like, are the current models, the way that we are building them, is that actually possible to get to the next thing with this way of building, as opposed to needing them to learn from kind of human interaction, which I think is a different question. Sorry.
Do you know this question that you asked? There was a physicist had a very simple way of testing this, how much your agents are going to be useful, And a grand conclusion of this paper that was published actually in Cambridge was, well, the difference between humans and any machine that we have nowadays, except quantum, which we don't have, and we won't have for the next 100 years to come. But anyway, it's that we question hypotheses as humans. And so they did a simple experiment, so you don't have to know the details of complicated particles and dark matter. So we went to one thing that everybody knows, right? Beginning of science after Middle Ages is Galileo, right? So he claimed that Earth is round, right? And not flat. And so they have actually trained all the AI models with the literature that was available. And so basically they ask AI, okay, be a trial Galileo. And the grand conclusion, you guess what the conclusion of AI was?
Flat.
That, yeah, he should be killed. And Earth is like Giordano Bruno because he's a lunatic, Earth is flat, blah, 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 And he cannot question, and the grand conclusion was only humans. So if you're trying to actually make an agent work, it would work in a quantum space because you have infinite amount of possibility and correlations, just like between humans. But we don't have that machine. And yet, okay. That was very interesting, actually, reading about Galileo. So be careful using it.
Yeah, you could end up getting killed. You've been both of you have talked a little bit about your fields and your field's relationship to AI in different ways. But what about in your own actual work? Like, what's a thing that you've done that that was either, it could be a positive or a negative AI experience, but like an engagement that you've had with the technology.
I'll start. Okay, I started, quite a few years ago now, like 8-9 years, very deep on deep learning, like more advanced AI algorithms. It was actually a risk. I was postdoc at that time in Santa Barbara, and I said I don't want to just turn the crank and repeat an analysis. So I take a year off. I said to my boss Joey Candela at the time that we have to work and develop a tool that can open up new phase space, new parameter space to study properties that previously were written off, right? So it was a risk. It paid off, but I started first classification task, like to identify the separate, discriminate between different types of particles. And there, of course, there is a revolution where aggressive approaches, but based on conservative steps, like I don't want to be very technical, but convolution neural networks, and then graphs and transformers, which was the main topic, let's say, of my research, like graphs to exploit correlation in kind of unstructured data, which is kind of what we have in these big experiments. So this started classification, but then many other topics about clustering, grouping particles based on the similarity, also developing and implementing on hardware, like on FPGAs, gaming hardware, because you have to take decision in microseconds, right? So you have to fit something huge in a tiny, like very small resources.
I see. So one of the benefits of AI in that setting is just that it can make a decision that's maybe not as good as a person, but it can do it so much faster that you can actually...
in the selection, but it's not, I mean, we had to, this algorithm we didn't take from the stock. We have to get inspired by how self-driving cars work, for instance, the notion of point clouds, right?
Okay.
But then you get inspired by this, but you transfer these techniques in physics, so you have to understand the physics, and you help it with some physics, but there are also patterns that you don't know the physics, in that detail that you're trying to improve the algorithm. And you can think about as reverse engineering. The algorithm learns, and then you go back and see what this algorithm learned and deepen and expand our knowledge in physics.
Are you building your own LLMs?
Yes,
Yeah.
yes.
Seems hard.
Not everybody does that.
Yeah.
But can I say one more thing?
Yeah, please.
So I'm actually coming, as Kevin said, I came to Brown a couple of years ago. Before I was at CERN, which is the biggest laboratory in the world for part P physics. So people there are excellent. You can think about it, but I'm not saying in a bad way. It's kind of narrow excellence, right? You focus, specialize on this specific topic. Universities cannot build this, but they have a strength cross-disciplinary. So, as we discussed before, CS, getting a very powerful model from people developing computer science is not going to solve our problem. It will fail miserably. But combining this knowledge, this domain knowledge, I think it's a strength compared to dedicated labs and centers. And I think we should, we're doing it, I'm not saying we don't do it, but I think this is something that we should be proud of and try to embrace it and work hard. Same for economics, for instance, CS+. It's the breadth we have and the depth, of course, at the university.
Okay. I have used AI in more limited ways, but let me tell you one thing that we did that I thought was very good use of AI. So one of the sort of projects that I run is a project about state level test scores. So in all U.S. states, in grades 3 through 8, they give kids tests in math and ELA. And I sort of run a kind of data project where we basically take those test score data and clean them up and make them kind of comparable in the sense that the files look the same. So this is a thing that is of value to a bunch of nonprofits and researchers and so on. So there's kind of a data cleaning aspect of that. And we were working on that project. We wanted to so my initial instinct, because I'm an academic, is if only the Excel files were beautiful and nice, everyone would be able to use them. But then it turned out that most people are not able to learn a lot from detailed Excel files, even if they are very clean. And so we wanted to sort of take the next step and be able to kind of turn the data into something where people could explore it, even if they were not like in a position to sort of put it in R or put it in Stata or whatever to make their own graphs. So we went to OpenAI and asked them for some help, and they got us a person. And so we built a kind of front end on this data, which is a chatbot. No, it's not a chatbot. It's like there's a front end on the data, and you can ask it to make graphs or tables and like sort of on the data, and it will produce those for you. So you can say, make me a picture of the test scores and math test scores among third graders in Rhode Island over time, and it will generate that image. And it was an extremely interesting project because the biggest issue for us here was like hallucinations. Right, so we did not want, and we were building this sort of maybe 2 years ago, so I think it would be better with the frontier models, but as we're building on maybe GPT 3 or 4, probably 3, and those chatbots hallucinate a lot, right? And so you don't want, in a setting like that, you don't want people to be able to say like, what's going on with test scores in Rhode Island, and then have ChatGPT be like, well, Rhode Island's school system sucks, and or have it say like, you just don't want it to hallucinate, you don't want it to make something up. And so the way that we structured the chatbot was really a sort of pure translation. Basically what it does is it translates the thing that people ask into SQL code, and it runs the SQL code on the data. And then it produces something. So it is possible for it to be wrong. You could say, give me the math test scores in the third graders in Rhode Island, and it could misunderstand you and make you a graph for Massachusetts. But it would be very clear what that graph was. It shows you the SQL code, so you can see the SQL code that it ran. And so we sort of got to a place which is like a little more limited than if you really like let the bots go, but enabled us to kind of make the data sort of more accessible without the hallucination problem.
That's a really interesting way to take it. Yeah, right, because you can't sort of believe what it says, but in this case, it's sort of forced to show its work.
It's forced to show its work, and it's forced to show you something that is definitely right and is definitely a thing that you would get out of the data.
Right.
And like whether it is exactly the thing you hoped for out of the data, I don't know. There's a little bit of prompt engineering, but it isn't able to it's not able to lie in a meaningful sense.
Yeah, I was about to. How are we on time? Do you want to ask?
Yeah, I wanted to ask a question about, it kind of goes back to the initial question about discipline, but also certain convergence between your two fields around the concept of AI as being a tool. And I wondered how that concept affects the way you teach students to interact with this tool. Like, how does it change the way the discipline is taught to students to prepare them to be able to interact with this tool?
I mean, so I think for me, it's like different. It's maybe not different, maybe sort of the same for graduate students and undergrads, which is I will tell them like, this is a great way to make your code, like to code faster. This is a great way to like, this is a tool that you should be using to like make your code nicer and make it go faster. And that it's also a tool that you can use in writing, because most of our job, like if you think of like what is the value that you are giving in the academic paper, it's like having the idea, structuring the analysis. It's not usually the writing. Now you cannot tell your chatbot to write your paper because it will come out weird. But you can use it, people can use it to kind of like fine tune. It's a better editor than generator, I find. And so I think those are the, I tell my undergrads, you can use, I let my undergrads use AI for their things, but I tell them you can't produce, like don't hand in a paper that is written by AI, and I will know if you do.
Do they have to reveal how they've used AI?
Yeah, I tell them like, tell me what you did, but I think it's not, I actually don't care, like, I don't care too much except, I have had people hand in like a paper that was obviously written 100% by AI, and then I just failed it, and that was fine.
What about in physics?
Yeah, so actually I see also a couple of my students here in class, so I highly disfavor using LLMs, or it's tempting, but I don't like using it while they're learning something. So think about it, you go back. I remember I did some calculation, painful, like 30 pages calculating. I don't remember how to solve it now, but I know I've did it. And as we said, oftentimes in physics we are in front line of AI development. Some challenges we have, they are not like mainstream that big tech companies try to solve. So in order to extend the knowledge, bring something, you have to know very well the fundamentals. So when you learn something, my advice is do it yourself. It's painful, but there are no shortcuts to success, right? You do it once, then you can use it, of course, because we need to be more productive. So there, I highly disfavor it. I tell them I'm not going to do the police. If I pick something, I will be very unhappy. Where it could be helpful, and I would like to try the next time I'm going to teach this course, is that we ask for some prior knowledge. So I can ask, for instance, ChatGPT to prepare a set of questions, right? And maybe some summary of the required knowledge, and I can pass it to the students a month during the winter break or summer break to go through these questions and through this document, which I don't have to go through. It's important as a fundamental tool to follow the topics, but there I think it will be helpful. But in my class, I'm not in favor of using it.
And you have some students here.
I
So,
guess
so,
you
all right, so
I'm
Lucas,
not
Are
going
you
to-
using
I'm not going to
AI?
point-
Lucas
Lucas's
said he
class?
highly
I'm not going to point
disfavors it.
fingers,
Close your
but-
eyes.
No, they don't use. I'm very happy. I mean, they're excellent. Yeah, you know,
No,
I was
but
not-
there's a thing that you said that I think is really interesting and important, which is there's no shortcut to success, and
Yeah,
it's
no
really painful. And I don't know about your students. I kind of know about your students. We don't love pain. Like we kind of try to find ways of minimizing pain. And how can we be free? And maybe that's not true in physics. So I take it back. I know that when I took a physics class, it was like, oh wow, maybe I shouldn't take any more physics classes. But so to the extent that that it really does reduce pain, like how can we say this to our students in a way that is convincing, right? Because I really do believe that maybe pain's the wrong word, but like the struggle is real, and the struggle is important, and it's formative.
Maybe I should use struggle. That's why they get,
Yeah.
you know, don't like
Right?
pain.
Right.
Yes.
So like you don't love it, like the struggle. You don't love the struggle, but like that is the way you get to the other side, and that's where that knowledge actually becomes built inside your head. And I don't know. I know that the students who I've spoken to, I know they believe that verbally, but I think in the moment it's very hard to turn that off and say, oh, this thing's going to do my homework for me, and then I can eliminate the pain. It's probably fine this time. So
It's tempting, it's very tempting, but then in the longer term, to get the next position, to publish papers, it has to be unique research, innovative research. How you can do innovative research if you rely on mainstream tools?
and you
Take
feel
off
like
the
if we just message that strongly to students,
think
that
that's
they're
Feels to
going
me
to.
like
Yeah.
it's like, why do we teach people the multiplication tables? Like why don't what we have calculators?
Yeah.
Like why do my fifth grader have to spend all this time, like, you know, in the second grade, like learning the multiplication tables? Why do we show him a little box, 2 things by 3 things? Why don't just be like, here's a calculator, put the number 2, multiply the number 3, it's fine. The x is the multiplication, don't worry about it. And the reason is like later to build on that, you need to understand what multiplication is, even though you are not actually going to need to, like your life would go on if you didn't know what you didn't have that memorized. And I think it's the same.
Exactly.
the same
Actually,
idea.
AI is what is linear algebra, calculus and statistics. So it's high school and maybe a first couple of years of undergrad study. So it's not a black box. I don't want to trivialize very much, but at the core.
I also think if people understand more about how this works, this is like a general question, not so much for students, but like for just people in the world. If people understand basically, fundamentally, it's sort of like guessing the next, like these LLMs are like guessing the next word. They're using a very, very complicated version of like guess the next word that is like the most predictive. That actually really, if you explain that to someone, they're like, oh, like that is a really easy, like then it is much easier for them to understand, like why is it hallucinating these citations? Like, why does your AI make up citations? The answer is it's guessing the next word. And like Loukas has written a bunch of papers with similar titles. And it's like, well, I guess the next word is, particle. Right? It's like, wait, he uses that word a lot, and maybe the next word in the journal is physics, because it's like, it could be a paper, and it seems very plausible because, of course, it's like, because of exactly the way it works. And I think that kind of like, there's a little bit of like, people think this is magic. And if you're just like, it's not magic. It's just like linear algebra and, tokens.
Let's open it up.
Oh, it's a great idea.
Should we open it up?
Yeah.
Yeah.
Any reactions,
Reactions, questions, new,
concerns?
right.
Let me. Oh, yeah. Go ahead.
I actually had a question for Emily, because I'm also coming from this kind of a particle physics perspective, where we have these, like Loukas was talking about, like very specific classification tasks, right? And so I was just wondering, in economics, a lot of it seems like you're really worried about like causal stop, right?
Exist.
But from a physics perspective, we kind of know the physics quite well. And so we just need to classify things that look like what we want to look at, right? Look at like this data that we want to look at, and then we can look at it later. And so I'm just wondering if like, especially as a micro person, if you're ever concerned about machine learning or AI in general hiding causal structures, it'll just spit stuff out at you, right? Is that
Totally.
like a problem, a barrier?
Yes, yes. I mean, I think partly because it is, there is I think a temptation. People sometimes who do this, you'd be like, actually, we have a lot of data, and you can run it through one of these and be like, what predicts blah, right? Like, a way people have sometimes used, particularly machine learning, but some of the sort of, these overlap a bit, is like let me predict who in so when people come into the ER, who is going to be readmitted? Okay, this is like an interesting question in health economics. And so one way to do that is to say, I'm going to take everything I see about you from all this complicated data of your medical records and everything, and I'm going to run it through some AI, LLM, machine learning, neural net, whatever, and get out a prediction. And every individual is going to have a prediction. And that is sort of interesting in one specific way, which is that is interesting for one question that might be of interest to policy, which is when people arrive at the hospital, I would like to understand their chance of readmission so I can think about how to treat them differently. But it is not interesting for a question of what is it that causes this readmission, right? And I think for economists, we are sometimes interested in both of those questions, but you can get confused into thinking that answering that predictive question tells you something causal. Right? People will sort of be like, well, it turns out if you arrive in a taxi, if you arrive in an Uber, that means that you're more likely to be readmitted. And that's probably true, right? If you arrive in somebody doesn't bring you, if you arrive in you probably are more likely to be readmitted. But that's not because riding in an Uber is dangerous for your heart. It's because you don't have, that tells me that you don't have someone taking care of you, and that tells me you're more, so, and from a causal standpoint, that's the thing we would care about. And so I think we have to be a little careful about how we're using this stuff for prediction and not getting confused between factors that are predictive and factors that are causal. And that's so important within economics.
Oh, great. I guess I saw your hand first. Yeah.
Thanks very much for this conversation. I was struck by both Emily and Loukas emphasizing the framework as tool, or the tool framework. And then I was wondering, is the problem, or one of the problems with AI, fundamentally agential? How it acts as an agent, its decision-making, its apparent decision-making ability. We assume it's knowledgeable, and that we assume it has some sort of intelligence, therefore it can be an agent. But in fact, in practice, we don't trust it as such. So I'm wondering whether it's that role as opposed to a reference. It was also interesting that your example, Emily, was an example where the AI is sitting between you and a database. Mm-hmm. The database that you've been responsible for curating. And then it's trying to help you. It's doing what a data visualization team.
That's right.
Yeah.
The front end, yeah.
So being an agent, but perhaps needing a lot of attention.
People, yeah.
I think this is kind of the holy grail of AI, right? And I can say in my group, we are trying to actually use techniques like, for instance, reinforcement learning to give some basic rules, fundamental rules, how particles interact, provide information from CERN, from astrophysics, from neutrino cosmology, and then teach the algorithm so well the basic rules that starts proposing new theories, right? So think about it as AI-based model building, physics model building, that of course respect in the same time the constraints, the data that we have observed so far. It's difficult, right? It's active R&D, we're working, but this is kind of the holy grail in my mind, to not only to have AI that can improvise and propose things that you trust, of course. in physics is very important. Put aside that it takes a lot of time for a physicist to develop a model that is not an elegant mathematical model, but also respects the constraints we have with data. Also, there are biases, like preferences, which physics will like, which not. Like this, you can solve this, and it's kind of like leaving no stone unturned. But, yeah.
I think I would answer this somewhat differently, which is I actually think the biggest worries I have about AI are the places where its facsimile of humanity is so good that it is confusing to people that it's a tool. So the things that worry me the most are not like AI is going to decide to make everything into paper clips, including us, which is like this sort of like rando idea, but that like people will, that the sort of interaction, like this kind of like every kid's got an AI friend. It like, I think that's tricky for some of the same reasons that we sort of talk about like AI is not good at running your vending machine. Like fundamentally sort of human interactions require navigation of conflict in a way that kind of AI interactions don't always. And I think if we, like from a social science perspective, we have a generation of people who expect that like all of the interactions they will have will be with someone who will be like, wow, that's so great. You're so great. Like they're not going to find out that in your relationship, sometimes your partner's like, wow, you're a fucking asshole. And like, and then you have to figure out like, how do we move forward in that your AI never told you that.
Right, unsubscribe.
Right, exactly. It's like,
it doesn't work that way.
please use a different voice. It's like, that doesn't work on other people,
I totally agree, and I think you expressed it perfectly.
Thanks for the question. That was a very astute question. Your hand was up next.
So I'm in undergrad here, and I'm trying to think about, I was hearing the discussion about using AI as students, and I'm trying to think about the balance of learning the fundamentals of my subject, which is physics, but then also trying to learn how to use AI because it's going to be needed in the field. And how should I navigate using AI in a way that I learn how to use it, but then also learning the fundamentals of physics?
Great question.
It's for you.
2 of these classes there.
Yeah.
Take
join my
his classes,
you know.
apparently.
That's a very good question. I think it should be synergistic to your learning, the AI, not replace learning. I think I go back to what I said previously. For me, it's important to follow the traditional approach, at least to a very large extent, to struggle a little bit, no pain, but struggle, because this gives you also the confidence and of knowing these fundamental concepts. Then you can use it like AI, if something that you try to find, as we use Google. I mean, a few decades ago, people were going to libraries, searching for a book. It was not in the library, available in the library. Now we have Google. Things makes things much faster. On the other hand, we have to deal with much more complicated problems, right? We get easier access to information, but we try also to solve much more complicated problems than before. Also, we have the prior knowledge. So to me, I don't see a dividing line between AI and more like traditional way of knowledge, as long as AI is there to assist the knowledge rather than replace the traditional approach. Then if you know something, and remember we learn as via Newton approximations in steps, right? Gradually we go in depth. You start using more and more AI because you want to be more efficient. So this will be my advice. This is what I would do, hopefully, if I was a student now.
Yeah, if I can maybe quickly add to that, I would say probably it's just an extension of learning how to code, like learning how to, because you want to know the physics, but to do that you got to analyze the data in a certain way, for which you will need computer code, like Python, C++, whatever tool you want to use. You need to learn how to do that. And AI, I would say, is just, at least in the first step, is just an extension of that. It's just one other tool that you will need to analyze the data, to which you can then apply or interpret with your physics knowledge, which is content-wise very distinct. Like they're just two distinct things. There's like the knowledge that you have of your topic, and then the tools, knowing how to use the tools to investigate that topic.
One analogy that I have found really helpful is to think that when you're using AI, you're kind of being a supervisor. And you don't want a supervisor who's never really done the job, right? Like because they're not very good supervisors and they're not going to supervise work very well. So, but you need to know how to do the job. And at some point, once you really know how to do the job, then, supporting or having the AI support you by doing some of that work makes a lot of sense. But don't cut yourself off from that source of knowledge, because then you're going to be, I don't know, the pointy-headed boss or whatever. Like you're going to be like the guy who's supervising but doesn't really understand what it is that you're supervising, and that's going to end badly for everybody. There's a lot of hands. Very back? Yeah.
So I'm a historian, and I write about radio in
Oh.
the early years at universities. And I find a lot of interesting parallels between the way that we talk about AI at universities in this early phase of radio, particularly in the tension between the theory and the innovation of a new technology and the application and use of it. And that if you look at radio, it actually ended up being pretty institutionally destabilizing for a lot of disciplines. Maybe not electrical engineering, right? We didn't all become electrical engineers. We're not all going to become computer scientists. You start to see a lot of changes in fields of like rhetoric and English and sort of reshaping, media arts and these kinds of things. So I'm wondering if you see any. I'm a historian. I don't like to predict the future, but maybe other disciplines do. Do you see any potential implications for the boundaries between disciplines as we sort of grapple with this tensions at the center of this technology in the university itself?
That's an interesting question. Yeah, I mean, I think the place I thought you were going to go, which I think about a lot, is is the way we're talking about this the way that we talked about every new technology, like including both the promise and the fear, right? Like, is this like the novel, and then the radio, and then the telegraph, is the computers, television, like all of this kind of stuff where it was like, oh my God, everything, like now we have computers, like every job will be changed, and like that's there's like a period of transition. The academy tends to be slower to transition than the world, I have found. But I do wonder about the boundaries between CS and even about like the sort of like what will it mean for computer science when like everyone is using some kinds of, like, does that mean computer science is all of the disciplines, or like the sort of thing you're actually doing in computer science a bit different? We already are seeing, there was a world, not so much in a place like Brown, but just in general, there were like a lot of kids who like learned to code thinking that there were going to be jobs as coders, and there aren't as many jobs as coders because now there's one person supervising 5, Claude instances. And I think that is kind of that's a change which we will see reflected in, if we've already seen reflected in, what people are majoring in. I don't know.
Yeah, I agree with you. I don't think it can replace us, or not anytime soon, at least the physicists, for instance, and I don't see it happening, right? So, but also as people, we have to learn to adapt to new technologies, right? We have to incorporate them. We incorporate the mobile phones, we incorporated the internet and Google. By the way, this was invented back in 1989 at CERN to transfer the data, right? It was a physics problem. That I'm a bit biased, but bear with me. Okay.
Here are different important things that CERN invented. Number one, the internet.
So, because now we want to
World
build
Wide Web,
a
anyway.
big collider, a 50 billion program, right? And if Lee was, we could patent at CERN this development, then we didn't have to worry about money, But anyway, a small parenthesis.
We're sorry.
But it's a tool. We have to adapt. We adapt. And a tool doesn't take anything away from the. A tool is very important. We, as humanity, we learn to use tools, right? But we have to learn how to use those tools to assist us. I think there was a paper I read someone many years ago that on average people change like 5 to 6 types of jobs during their career, the professional career. I mean, we have to learn to adapt.
It reinforces for us, actually, it's a good thing. It reinforces that we need basics.
Exactly, we need this. Exactly, yeah. So it's good for our physicists. Will stay. We will be needed.
All right, so we're almost out of time. So we both saw you raise your hand, so we wanted to make sure you got in. But if there's a couple other people who wanted to say just a word or two, just so that we know what you're thinking, feel free. But why don't you ask your question?
Just following up on the things that you've answered before. what more do you want AI to do in particular for your fields that you feel like would really help you in more ways than it already is doing?
Oh, that's a good question. I don't know. I'm tempted to answer like, I wish they could write my referee responses for me. It's something I don't like. I'm not sure. I don't know that we are. I think the reality is, I think that in my field we are not using the frontier of this enough as it is. Like, there's like way more on the kind of like, what are people coding, where like it's hard because we're old. Like the sort of the fact, like I'm old. And like I am too old to learn how to use Claude Code, and so like the next generation of kids are going to be better at this, but it just takes a very long time inside the academy because the kind of technological frontier moves, but the faculty are still using Stata. We move, but we're still using Stata, which
Yeah, I don't know. I don't think I can answer this question. I can tell you that the more we learn, the more our appetite opens, and we want to learn more. So we're always going to ask more from AI, from our detectors, from our theory colleagues. It never ends. We are not going to discover everything. It will go asymptotically at some point, but asymptotical means that you need infinite time, effectively, to reach the knowledge. So, yeah.
See, if you can't talk to a physicist without Newton coming up, which came up earlier, and talking about the heat death of the universe, which is, I feel like, where we ended. So do you want to take us out?
Yeah, thanks very much for coming. Please give us some feedback. You can use the JNBC website if you want. We're going to be doing some more of these in the spring. So if you have ideas, please let us know what they are. And I want to really thank both of you for saying yes.
Yeah.
Thank you.
Thank you.